in the back of our spiral, and it means f of g of x. However, that's not how we do this thing, right? So, what did I mean by
Like the bunch of parentheses.
bunch of parentheses, right? We have f, parenthesis denoting of, g, parenthesis denoting of x, yeah? And what happens whenever we have function notation with something other than x inside? Plug it in, but where? We wrote it yesterday. Not for what x? This one? That one?
No, that one.
That one.
That one.
Right? Because we have to line it up and say f of who? F of g of x. And so instead of writing x plus 2, technically, to be all specific, we would write g of x plus 2. Right? Take out the x, put in the g of x. Then we say, who is g of x? Exactly. 4 minus x squared. Right? Plus 2. And as good math students, what would we do to finish it off? Not factor. Combine like terms, right? 4 minus x squared plus 2 is the same thing as negative x squared plus 4 plus 2, which is the same thing as, just a few of you get a little confused when there's like a minus after a number. You might have done that improperly. But if you see it as a negative or adding a negative x squared, then the 4 plus 2 is of course of 6. Of course of 6. How many individual people got that right? Okay. How many of you guys were almost there? How many of you are like, can we practice this a little bit more? Okay. So, to practice it a little bit more, let's go ahead and get out our comp books. Did we finish grading yesterday? I feel like we had some unfinished business in our spiral. We did all 1.6, 1.7, and then remaining questions we're going to ask today. Okay. All right, kiddos, let's go ahead and get back in our notes. Let's finish 1.8.
Yeah. Yep.
All right, back in your composition books. This is where we left off yesterday. We were technically on the page before, which was this one. We were just starting to talk about compositions. All right. We were just starting to talk about compositions. We've done one example in the back of our spiral, but we have to make sure that we're okay. So did it make sense maybe after the example that we started today with? All right, come on, group number 6. Just make a little more sense as to why I say, how do you do fog? All I say is fog. I don't know, it's a silly way of remembering that's not a time, so it's like a hollow circle, like an O. How do you do fog? It's f of g of x, and how do you do it? You take whatever is on the inside and plug it into the outside's x, or x's, however many they have. There's a quick little note about domain, but we'll work through that as you guys face homework and have questions, etc. Let's come back. Which one have we already done? A. So go ahead and pick up with B. Goff? Yeah, I suppose. Uh-huh. So we need to get some examples in our notes as well, because your notes are probably what you mostly look at when you do homework, right? It's not the back of your spiral. So let's try going the other way. F of g of x is what we did first. And I'm just going to write letter A really quickly just so we have it. This is just A. I'm just rewriting it really quickly. And real quick, because a few of you might have had this question, is there another way of writing A's answer, technically? Yeah, we could have also written it 6 minus x squared minus x squared. It means the same thing. We usually don't because we usually go descending order, right? The highest power of x followed by the next lower power, the next down to the constant. But technically you're right, they both would have been fine. But you guys are currently working on letter B, g of f of x. My warning to you is don't kill any puppies or seals. You might want to check out those two mistakes up on the wall. Make sure you don't kill any puppies or seals. Remember, what's shown is wrong. There's a proper way of doing it. What's shown is what's wrong. Take a second, check in your groups and make sure at least you're starting the right way. Some of you have already finished. Check the work as well. Go. Just checking it and seeing how far you've gotten and if you guys agree. It's similar.
Yeah.
You don't just you're our speaker.
Minus x squared, x plus 2 squared, and then I use x squared plus 4x plus 4 minus 4. And that's x squared plus 4. It's not like x squared. 4 minus
I got that at first, but then I think you see it. So that,
Yeah. So not just in front, but specifically where you're supposed to go.
Oh, wait. Yeah. Oh,
because it's
it still counts as 2 meters, but I screwed up.
I got it the same.
Yeah,
But that doesn't change the sign of.
That was after
So
you.
4 minus.
No, you just showed me that.
If I were you, I would take a quick peek at the board and see if you were thinking the right way.
You just killed seals.
I'm
Pretty sure you just killed the seal.
Double check, did you guys start the right way?
Yep, those were seals. You just killed Ricky.
I think I killed.
Oh, you do it. Job.
It's a cute little baby seal too.
Does that
Spiky hair. Okay.
Seals. That's what you do in big order. Like that's the term.
Alright, come back in. Question. What's supposed to be inside the x of the g?
X plus 2.
F, who is x plus 2? Now, take a peek if you haven't yet, looking at the puppy and the seal. Like, why was she making a big deal about that? Change that. I take the 4. I keep the 4 the same is a better way of putting it. I keep the 4 the same because there is no x that needs to be plugged in for. I keep the minus the same for the same reason. I keep the squared the same for the same reason. The only thing that gets substituted is the argument, which is just the x. Does that make sense? Which was technically what we did in the other one, but it was a little bit easier, so maybe it was a little bit harder to realize fully what was going on. So now we have to simplify, and kiddos, if you simplify properly, what would you have gotten next? Next, not the end. What is x plus 2 quantity squared? Nice. X squared plus 4x plus 4. How is this gotten? Squared squared? No. That's killing puppies. X plus 2 times x plus 2, first outer, inner, last. Combine the outer plus the inner, 2x plus 2x is 4. Right? But we're still not done, because what else do we have to do? Distribute that negative all the way across, getting, do any of you guys do it like this, like in the problem itself? You put a little plus and you go, hey, let's make it opposite, opposite, opposite. That's what I do. Could you rewrite the entire thing? Yes. But I like just bringing it in and making sure I have it all. Then I can go ahead and say, oh, hey, 4 minus 4 is 0. But just in case that's not you, you would have gone ahead and did subtracting the x squared, subtracting the 4x, subtracting the positive 4. Then you could have simplified by, there's a 4 on the first, there's a 4 at the last. What's 4 minus 4? 0. And so all you are left with is negative x squared minus 4x. Could you like pull out a negative x and factor and do snazzy things? Yeah, sure, of course, why not? But that's fully simplified. They didn't say we had to factor, so we can stop. How many individuals got that far? How many of you guys killed a puppy? Killed a seal? You're proud of it. That's great. Don't do it again. Hold on. How many of you guys messed up somewhere in the plugging in? Just messed up. Just messed up. That's okay. We're practicing. We have one more example, though. Did you guys already do C? Okay, hold on. Let's go see it. Let's go. It's not times. It's not times. It's not times. It's of. Ready, set, go. Letter C. G of F of negative 2. There are 2 ways of doing it.
So you just do it like you would before. Yeah.
2 different ways of doing letter C.
I like what negative
Okay, well, you don't have an answer.
to do it. Interesting. Okay, do that.
Are you serious? Yes.
You guys have 4, right?
Almost though. Still let's go.
So you have the negative squared minus 4x, right? Previous problem. And then you plug in negative
Just
2.
kidding, I forgot 4x.
Okay. I need puppies first.
But he's not killing.
I'm a little disturbed by the
Okay,
conversation.
I got 4.
That's your brother.
I was just like to say, keep
What?
He's brother. Tyler, keep him in the blender because you're great. It's disturbing, but it's a great.
Yes, he did.
Wait, you guys consider it?
Yeah, because she's the one that just said she's one of the
A strange thing.
Okay, focus. Right or wrong?
Wrong. Oh, right. You just killed something.
What did I kill?
I don't know.
Either a.
I'm plugging f of negative 2 into the x of g. How do I find f of negative 2?
You plug it in.
Plug in negative 2 to f.
Oh.
Negative 2 plus 2 is 0. 4 minus 0 is 4. That's one way.
Yay.
But who had another way? There was another way, and it would. I think it would have been faster. Plug in the negative 2 to. You already found g of f of x to be negative x squared minus 4x. So how could we have found g of exactly f of negative 2? Say, oh hey, it's just when x is negative 2. So we could have plugged in negative 2 squared minus 4 times negative 2. We would have ended up with, some of you might have made this mistake, negative 2 squared is positive 4 times a negative. Negative 4. Negative 4 times negative 2 is a positive 8. Do they both end up with the same answer? Yes. 2 different ways of doing the same thing. 2 different ways of doing the same thing. So composition, what do I need you to remember whenever you see fog, F little hollow O G, or G little hollow O F, Or more specifically, when you see tons of parentheses, f of g of x or g of f of x, what are we doing with that inside? Plugging it into the outside, right? And where or how? Plugging it into the x, true? Of the appropriate function. Or plugging it into the x of the appropriate function. Now, that's how to find or to make compositions. But the same way that we can plug in, we can also struggle. The orientation's not working. We can also pull out. The same way that we can plug in, we can pull out. And since you guys are talking about killing things, let's talk about decomposition. But not decomposing poor little puppies or seals. Decomposing functions. You guys scare me.
Yeah, that's right. Great world class.
You guys read the example, try to figure out what it's asking?
Oh, sure.
I'm just writing them as I write.
Did you at least make millions in sponsorship deals?
Okay. We're looking inside out.
That was good.
We have a put together composition. We have an H that's been put into a G that's been put into an F. But we need to figure out who is H, who is G, and who is F before they were composed. Who is F? Who is G? And who is H? And question, what was my little hint up here? What did I say to start? With the outside or with the inside? Inside out, meaning start on the inside and work your way out. Now, in the F and the G and the H, who's the innermost function? H. Now you could say X, but who is X in, right? He's an H. So H is the innermost, hence why I technically wrote him at the very top of this little breakdown of my functions. Now, we have to ask ourselves the question, looking at this function, what is in the innermost part of this function? It's kind of hard until you realize what we're looking at. But what is the most inside? What is in the innermost part of the function?
X+1.
Think little Matryoshka dolls, like the Russian stacking dolls. What would be in the very middle? X plus 1. X plus 1. David. Because h of x has to have an argument. You know what I mean? He has to have an x. Now, that's that one. And we don't just go to the outside because there's like a middle, right? There's an innermost and there's one outside of that and there's another one outside of them all. So now we have to ask ourselves the question, what is x plus 1 being plugged into? What is the next layer? X squared, close, minus 2. Now hold on, pause. Can you see it? Can you see it? Take the H. He would go into the G, right? He gets plugged into G. Does x plus 1 plugged into x squared become x plus 1 squared minus 2? Yeah. See it? What is this in? take out the x plus 1 and say, oh, hey, you were just an x before, x squared minus 2. But there's one more that's hiding.
Square root of x.
What's outside of them all? Square root of x. And who's outside of them all? F. So how could you double check that your decomposition, now we've been talking this out, so most of you probably trust it, whether or not you understand it. But how could you check that you were right? Plug it in. Put x plus 1 inside of x squared minus 2, and put that inside of a square root. And some of you can see, oh, hey, it works. So let me give you another example, and let's see if we still have it. Ready? Let's do one more, and you guys do it all on your own, in the sense of you can work with your groups, but not with me until the end. I want you to decompose this function, which basically means I'm giving you, and I'll do just f of g of x again. Sorry, of h of x. You're just trying to break it apart and say, who is h, who is g, who is f? And let me go ahead and give you 1 over sine of 3x minus 5. Woo! Go.
Okay.
Ah, come on, I had to make it harder. Go.
I can do it.
You can do it.
I think I can.
It's not sin, it's sine. Hopefully we know that. I hear people asking what's the innermost. That's perfect. Start there. Once you have it, help your group out if someone's struggling. Or check and make sure you make a mistake. Because I have 3 pieces. So I have to
Sin x.
That makes sense. Have we all compared? Go ahead and compare if you haven't yet.
Checking my answers.
You guys talk it out? Talk it out. Group number 5, you're too quiet.
So, this is the innermost part. I'll sin x. I'll sin x.
Oh, that's in the camera.
We understand why you said that.
The first one is minus plus minus 5.
Come on, cool kids. Who's the innermost? Anybody, everybody.
Minus 5. Minus 5, really. Yeah.
I agree. Not sin, sine. Now I need something else.
G of x. G of x is sin sine x.
Sine, but you need an argument. Replace the box with an x, and you have sine of x. Not just sin. Sine has to have an argument. You could put parentheses if you want. You could leave it without parentheses if you want.
Yeah, why? So why does she need an x?
Because the only way to plug in is if there's an x to plug in
So then what
to. No. Because he is going to plug in to take the place of, right? Right? Substitution is going to replace.
Oh, that makes sense.
It's going to replace. Stop judging. Okay. We're not done. All right, hold on. Slight whispers to your group might be fine if you're asking pertinent questions. We have one more, right? Let me go red.
We have another one? Oh.
Don't we?
I thought you were the
This is in, I heard it, say it louder, you were right. Nice. Does it make sense? Break it down? Break it apart. Okay. Alright, kiddos, hold on. Time out. This is the end of section 1.8. However, if we look at the backboard, what were we supposed to do today?
Dang it.
Get into section 1. We still have time. We need to get into section 1.9, but do you remember last night you remember last night what I said you could go home and do in sections 1.6 and 1.7? We checked all the evens yesterday, but what didn't we do? We didn't talk about any odd questions. So, before we move on to section 1.9, I don't want to get too far ahead. Were there any particular questions from section 1.6, section 1.7 odds? Open up your spiral. Unless you're like, I didn't even look, well then I guess it might not really help. But you were supposed to look last night, and if there were any odds that you were like, I know what the answer should have been, I looked at Calc Chat, and I just don't get it. And remember, I don't always think Calc Chat does it the best way, and sometimes even the right way. Were there any odds on 1.6, 1.7? Just raise a hand if there's something you want to see. On which one?
On 1.7.
Okay, what else? 79. Yeah.
12 and 1.6. I mean, I didn't really.
That's
see it
okay. We can think it's
yesterday.
12. We can think it's 12.
Thank you.
You're welcome. Anything else? Couple more seconds. People are looking. I want you to keep looking. Odds and or even.
Oh.
1.6 or 1.7. It can be either one.
Wait.
Alright, are we done? Hey, speak. That's work for us to do, right? Okay, section 1.6, let's speak at number 12 really quickly. I think this is 1.6. Alright, Ricky, what were the directions in number 12?
It was to write the linear function and graph, sketch and graph.
Alright, everybody, use this as a review. We have a test coming fairly soon, next Tuesday-ish. Maybe next Wednesday-ish. I think Tuesday. Use it as review. If they ask us to find a line and they give us this information, what does this information stand for? Y's and X's. Specifically, f of x and its y. F of when x is 1 and its y. Oh, that looks hopefully a little bit easier. Because with 2 points, what can we do? We can find a slope as y2 minus y1, which would be negative positive 10. 2 minus negative 8, and 1 minus negative 3, that'd be a positive 4. We can reduce that to be 5 halves. That's all well and good, but what do they want us to find? Yeah, they want us to find the equation, so we need to go ahead and plug in somewhere, and if I were you getting ready for calculus, we should plug in the point slope form. I would plug in the prettier point just because he doesn't have negatives or weird big numbers. So y minus 2 equals 5 halves. X minus 1, and with some quick simplification, you should have gotten y is equal to, do you guys have the right answer? 5 halves x minus 1 half. Ricky, does that make sense? Function notation makes everything look weird. We just have to think of what is it truly. Number 79 on 1.7, and then we're done, yeah? Alright, let's go find 1.7. Whoops.
Whoa.
Magic is happening over here. There we go. Alright. There's 1.7, there's a car. There's lots of graphs. Still coming. Okay. Where is he? Oh, there he is. Management. Do words ever look like they're spelled wrong, but they're really not? Anyway, management, that's weird. Originally predicted the profits, sales, approximated, actual profits, used transformations. Okay, so this was the prediction. This is what was predicted to happen. This is what actually happened. Starting in A, and then in B, and then in C. So we're supposed to think of, okay, this is what was there originally. Nice thing is they gave us a verbal description, because it'd be a little hard just looking at the graph. So they didn't give us like representative points so good. But my question to you is, before you can do this problem, what's X and what's Y? Meaning, from the word problem, what are the X values? Careful.
Oh, Y is
Y is profits and T is time. Good. So we can kind of say t is time. So we can say that y is profit. So these are profits. All right, my silly ones. Shush. And time. If the profits were only 3/4 as large, is that addition or is that multiplication?
That's multiplication.
Multiplication. 3/4 of. That's going to be multiplied. And profits are y's, right? So if it's profits being multiplied by 3/4, that's going to be a vertical dilation by 3/4, which means, isn't that going to be something to the effect of 3/4 on the outside of my function f of x? Right? So on the outside, because it's vertical, and we can see it's a vertical shrink by how much, and they told us 3/4. Then letter B, okay, that's different. Is that a dilation or is that a shift? And how do we know for sure?
Shift, because it's moved.
It's shift because it's not at the origin anymore. So it must have been somewhat brought up. So it's going to be a shift. And how do we know over here? Greater than, right? Greater than is like addition in the sense of, oh, it's that much more. Just add that on. Oh, add that on to what? What changed? The x or the y? So therefore, I'm going to go ahead and take my f of x, my prediction, and add $10,000, right? And then sadly in letter C, now I have to lose all this fun stuff that I wrote, but that's okay, we got this, right? Letter C, it says, there was a 2-year delay in the introduction of the product. That's practical. Every now and then there's a delay, so it doesn't get released as soon as they would have liked. So if it's a 2-year delay, once again a shift because it's been removed from the origin. It should shift horizontally, right? So therefore, where am I going to put this shift? On the inside. I've been saying x, I apologize. I should have been saying t all along. So let me go ahead and make it proper in here. It's going to be f of t because that's our variable for x in this problem. And how do I move to the right to?
Minus 2.
Sorry, guys.
Plus would go to the left. Minus goes to the right. Okay. All right, cool kids. Let's go ahead and get our composition books out. Those were the 2 questions that you guys had remaining. If some of you were like, oh, I had more questions, you have to follow directions. Have them ready, and then I would love to go over them, okay? Here we go, section 1.9. What on earth is going on here? Here we go, section 1.9. Start from today, finish in tomorrow. Double checking on our calendar, that's what it looks like, right? Start 1.9. Yeah, finish in tomorrow. So homework on 1.9 is not due tomorrow. I apologize. I only partially updated this backboard. This is actually due on Friday. But if homework's not due tomorrow, but it's due soon, what is homework tonight?
1.8.
No.
Start 1.9.
Start 1.9.
Right.
So those of you that are going to be like out of the lockers after school, being like, any pre-cal? No pre-cal. You're wrong. Your pre-cal. Yes. And what is it? Start. Are we tracking? I'm just saying.
Wow.
You guys make some poor judgment calls sometimes. Just trying to remind you what the wise judgment call would be. Here we go. Section 1.9, inverse functions. We have 10 minutes. We can get pretty far in. In the olden days, just kidding. In Algebra 1, I'm going to go back just for a second. Pencils down. If you were to see something like this. No, it's not a word problem. Write the following with positive exponents. This was a thing. Still is technically a thing. We just haven't reviewed it yet this year. And I was to give you something like 15x squared y to the negative 3. Oh, come on. Can we remember, Tyler? How do you do it?
15x squared y to the 1/3?
No, it's 15x squared.
Caleb.
It's 15x.
No, it's not a radical.
Oh,
15x squared over y.
Oh, I know.
Oh,
Better bet it. Sorry.
Negative exponents mean we need to take the reciprocal of that variable. Now, what if I was to give you a different one, and this is where it gets a little bit hard. What if I was to do something like 5x to the negative 2y cubed all over x to the 4. Woo-hoo-hoo. So fun. Okay, come on.
Y squared. It's 6 to the not 6.
The 5 is the 5 is the 5, yeah? The y cubed is the y cubed is the y cubed.
5x to the 4th over x.
Not to the 4th, to the
Minus 6.
negative 6.
And put that down. And then you put that
Like bases dividing, what do we do with the exponents? Subtract. Negative 2 minus 4 is negative 6, but this isn't the final answer. It's one step in the process. How do we express it now?
Yes.
Why can't you just always add the 2 to the bottom?
Or
Yeah, why didn't we do that?
Or you could have also gone a different route, and you could have kept the 5 and kept the y cubed and moved the x squared to where he should be, and then said, oh hey, like bases multiplied, what do we do to exponents? Oh, if you like that better, that definitely was another route to go that would have also worked. Why am I showing you all this stuff with negative exponents? To remind you what they are, right? Negative exponents means, basically, hey, he's up top, put him down bottom. Oh, he's up top, put him down bottom, right? Or, similarly, if it was down bottom, we would put him up top if there was a negative exponent. But, in section 1.9, what do I say this notation is not? But wait, we just talked about how it's the reciprocal. You move him down, you flip him. What's the big deal?
Because it's not the negative first.
This is not indicative of a negative 1 exponent. This is a notation. Check it out. This is a notation, okay? And it does not mean f to the negative 1 power of x. I didn't write that. What did I write in quotes as how I want you to read this phrase or this notation? F who?
Inverse
Bingo. I need you guys to like box it, highlight it, underline it, star it, something. This little negative 1 is not a power. Now some of you are like, but why'd you just spend all that time? Because negative 1 is a thing. But if we were trying to do the reciprocal of an entire function f of x, we would put the entire function to the negative 1. And if we put the entire function to the negative 1 power, then we could say 1 over f of x. But are these the same? No. These are not the same. And to be honest, you probably will barely ever, if ever, see that because we don't want to confuse you. Math books or myself. We're not going to go writing weird stuff like this. We might have x's or y's to negative powers, but not whole functions. That's just confusing. So, I need you to know the difference between this negative 1 inside the function notation and this negative 1 outside the entire function. Okay? So, this one, read it for me, everybody. F inverse of x. This one, the function f of x to the negative 1 power. Okay? Different, not the same. Sorry. Confusing. But different, not the same. You could say the entire function f of x to the negative 1 power. Or you could just say the reciprocal of f of x. Okay, let's keep going. So who are inverses again? Have we seen them before? Look right here real quick. Have you seen them before? Switch the x and y, solve for y. You've seen it before. Start for a second. I promise you have. Start at the top though. Start at the top and let's write some stuff down about it, okay?
Don't they reflect over like the x equals y?
That's my next page. You're close. You're just a little bit ahead. Definition of inverse. In homework at certain places, it's going to say something to the effect of verify that two functions are inverses. If it says to verify, it's asking you to use this test. And maybe some of you are like, oh, that's why we had to do section 1.8 first, because how do we test to see whether or not two functions are inverses? We find their compositions forwards and backwards. G into F and F into G. And if, when we plug in, everything goes away but the x, all the addition, the subtraction, the multiplication, the powers, the roots, if everything goes away, when we plug in for the composition, except for the x, if he's the only one remaining after we simplify, then those two functions truly are inverses. And if they're inverses, it would work the other way as well. Plugging in f into g, everything once again would be simplified out except for the x. And you guys have done inverse things for quite a while. Back in algebra, when you were given some sort of equation like 4x plus 1 is equal to 5. Okay? Algebra would tell you, how do you start solving? No. Sorry. Just this problem. You're helping an Algebra 1 kid. Do the inverse operation to each piece. Because the inverse operation of adding 1 is subtracting 1. Why? Because it removes it, right? And so then we have 4x is equal to 4. And then what's the inverse operation of multiplication? Division. We're undoing, right? We're undoing what's going on to the x. We finally end up with x by itself and the constant that it equals. That was Algebra 1 stuff. This is Precalc stuff, but we're still kind of doing the same idea. An inverse basically undoes the operations of a function. Now, what's the shortcut way of solving? To find the inverse that will undo everything being done, or all the different operations in the function. Switch the x and the y. Maybe there's just one of each, maybe there's multiple. Switch all the x's with y's, switch all the y's with x's. Then solve for y. However, quick note, making y equal to f inverse of x. You'll see what I mean with that in just a little bit, as time allows, or maybe tomorrow. Switch the x and y's, solve for y, but don't stop with saying y equals your inverse. You have to name it something new, or else it's just going to be confusing. And then since the x's and y's are switching, the domain of one, all the x's of one will become all the y's of the other. And since the x's and y's are switching, all the y's of one will become the x's of the other. Tomorrow, what are we going to do? We're going to solve for some inverses. How are we going to do it? Switching x and y, solving for y. What else are we going to do? Deal with them graphically, algebraically, and numerically. Bye, cool kids. I'll see you tomorrow. Happy Wednesday. Happy holidays. See you. I'll see you guys later.
No math homework.
Hello.